Welcome back. This is the third lesson recording for IM1, November 13th, 2020. So from all the Desmos exercises, we should have come to the conclusion that we can make predictions using the graphs of the scatter plot, so predictions graphically, or we can use the equation of the line to make predictions. So let's do some application problems here. Okay, so here we go. The number of marriage licenses issued by Clark County, Nevada, the county where Las Vegas is located, has been decreasing since the year 2000. So I don't know if you realize this or not. So there is Las Vegas. That's what they call the gambling city in Nevada. And this is where, if you really want to get married, you can go. And some people used to do that. They just go over there quickly because you didn't have to wait or anything like that. And there are marriage places, the wedding places everywhere. So in 2001, there was 139,000 marriage license. And then 2003, 135,000. And it has steadily been decreasing. And if they plot this, you would have this scatter plot that looks like this. Now, if you just have one point, you would not be able to make much predictions. But when you have multiple points, multiple data points, then you can start to see, oh, there is an obvious trend. And that's going to help me be able to predict what's going to maybe happen in the future, or maybe what happened in the past, or possibly what happened in the years that I did not have the data of. So this can be, and then this can be modeled by the equation y is equal to negative 3,577.8 x plus 7, let's see, that's 7,300,700, where x is the year and y is the number of marriage license issued. Okay, so that means that they've actually used the computer. The computer has used these data points to come up with the equation here. This looks very precise. So that's a computer generated equation where it has looked at how far, they basically, what it does is it tries as many different slope or many different places of graph and figures out what would minimize the distance from the line to each of the point. And they have a special algorithm for that. And so this is what the computer has said is the best line of best fit. Okay, so now we have a graph, we have a table, and we have the equation as well. What does the slope of the line represent? What is the slope given this equation? The slope is negative 3,577.8. Okay, because that is always the number in front of the x is the slope. But what does it represent? So the slope is negative 3,577.8. Why is it negative? Because it's going down. Okay, it's, remember the slope, dude, puff puff positive, nice negative. This is negative slope. And slope is another name for unit rate. That means every time of x changes by 1, how much does the y change? That's what the slope is. So every time x is changing by 1, x is changing by 1 means every time it increases by every year, each year, how much does the marriage license numbers change? By 3,577 marriage licenses. Okay, and in fact, it's going down by 3,577 marriage license, or I can write this as maybe 3,578 licenses. So I wrote the slope is negative 3,577.8. That means that each year, every time the x is changing by 1, that's each year, number of marriage license, that's the y-axis, license decrease because it's negative by 3,578 licenses. Okay. Now, the next question says, what does the y-intercept of this function represent? What is the y-intercept? Well, y-intercept is where does the y-axis, where does the graph um, intersect the y-axis. And according to the equation, it's this. That's my y-intercept. But according to this graph, it is approximately maybe 150,000. Why is that different number? Can you think about it? Well, that's because here the year is this is this will be 2004, 2000. This will be 1098. This will be 1098. Y-axis is when x and y is equal to 0. So this is just part of the graph. The graph has to extend much more on the other direction. And when it gets extended, this is where it's going to cross. So in this case, when in year 0, okay, there they were 7300700. So that's 7,300,700 marriage license in Las Vegas. Marriages. Okay. Now, does that make sense? Probably in year 0, Las Vegas did not even exist, right? So this does not make sense, but that's what the y-intercept is telling us. Okay, so depending on the different situation, sometimes the y-intercept will be meaningful. Sometimes it's not going to be so meaningful because you're making too big an extrapolation prediction there. Okay, according to the model, how many marriages licenses were issued in 2005? That means we are looking for year 2005. So we need to figure out where is my year 2005 first. 2005 is, this is 2004, this is 2008. That means right in the middle will be 2006. So 2005 will be in between. So it will be here. Okay, so then the graph meets about here. So from the graph, I would expect to be between, oh, I don't know, maybe this will be 1 to 8 0 0 0. Okay, that would be my guess from the graph. However, we don't have to rely on the graph. We actually have an equation. So the equation will be far better to use. So what is the x value in this case? X is the number of years. So number of years, this is my x. That means plugging it into the equation, I get y is equal to negative 3577.8 times x is 2005 plus 7300700. Okay, so that's the equation that I will be doing. Then I am going to pull out my calculator, and you can pull out your calculator too and plug that in. So remember, it's negative 3577.8, and it has to be negative times 2005 is equal to, okay, and then to that you are going to add 7300700, and that leaves me with y is equal to 127211. So that means there were 127,211 marriages, and that actually looks very close, 128,000. Okay, so I was a little bit off, but you can use the graph to make rough prediction, but the equation is going to give me far more precise prediction. So please make sure you understood this, because the homework for this afternoon is doing 4 more problems like this where you're having to deal with tables and equations and making predictions and interpreting it. So, and if you are having at all problems with it, then you should be coming to my study hall. So that's it for today. So for as a closure, I would like you to do a lesson wrap up card and card number 20 of the Desmos, and write in the entry in table of content. What did we do today? Today's date, we did sketching line of best fit and making predictions. Thank you for listening.